Okay, in this section, let's talk about statistical graphics, different ways that people represent the information in a graphical way. Here's our list that we're going to actually cover. We're going to take a look at frequency polygons. In the next slide, ogive. So that sounds like a dance move there, ogive. Dot plots, stem plots, bar graphs, Pareto chart, pie chart, scatter plot, time series graph. So we're going to take a look at each one of these really quickly. This would be a good batch if you're exposed to. This would be good if you'd be able to read each one of these. The proverb for this section: a fool takes no pleasure in understanding, but only in expressing his opinion. Another way of saying that is just to be open-minded, and in general in life, obviously, but pertaining to our statistics class, you're going to see some really wacky graphs, and that's what I wanted you to be open-minded about, that there are different ways of representing data. You need to make sure that the reader would be able to read the data and be able to make some conclusions. That's very important. Okay, so be open-minded. Here's the first one. It's a frequency polygon. Instead of making bars, vertical bars, there's just these dots that are made. And then these dots for the relative frequencies are connected with a polygon. Okay, so that's what a frequency polygon. These dots are connected with straight lines, and therefore there is a many-sided figure that results. Okay, let's take a look at ogive. Ogive graphs are basically the cumulative frequencies, the cumulative frequency column that is graphed. Notice that cumulative frequencies will always be increasing, almost always be increasing, but never ever decreasing. They could plateau, and that's something to think about. So think about this. When is a situation when I would be plateauing in my ogive graph? Because what this is a running total. Every single time I increase a value because I'm adding all of the values before it. So you would actually get the answer to that question. When is it be plateauing? When a particular class did not have any value points in it. Okay, so that's the answer to that. If a particular class did not have any values in it, then that frequency would be 0, and therefore you'd be plateauing with your ogive graph. Dot plots. Dot plots are a good way to just take tally of whole numbers. So please note that if the data type is categorical in nature, those are rabbit, right? There's no such thing as a dogly rabbit or a rabbity dog, which is weird. And so they're exclusive, and you would be able to count all of the dogs, all of the cats, and so forth. And same thing with test scores. Let's say if you round to the nearest percent, then here is a distribution of dot plots of these dots that say how many each person got. So it looks like there's 4 people that got an 85 on their test. So that's good. Okay, dot plots. Stem and leaf plots. You've probably heard of that phrase, but here's some examples. Here is raw data that can be organized into a stem and leaf plot. The stem would be the tens place in this case, and the leaf would be the ones place. And so the way to read this is, here's 32. 33 are data points from this graph. 42, 46 are data points also collected from this graph, and so forth. 56, 52, 57, 59. Notice that they don't have to be in order. It does help if they're numbered in order. And then just to find out how many total data points you have, you can just add the numbers. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth. That's the total number of data points that you've collected. There's also something called a two-sided stem and leaf plot, and that is when you have, for instance, girls and boys, whatever the context is, quiz scores or something, where you have the same stem for both of those two categories, namely, right, boys in this case and girls in this case. The other thing is if there's a values that are greater than 100, you would need to include a legend or a key. So in this last case here, this 1 and 0, think about this, if 2 vertical bar 1 stands for 210, then this 1 vertical bar 0 stands for 100. And so we have 100, 100, and if we get 1 here, 101, and so forth. So, excuse me, let me rephrase that. This 1 is the stem, and this 1 is the tens place. This is the hundreds place, and this is the tens place. So this would be 110, 120, 130, 210, 230, 240, and so forth. That's another stem and leaf plot, and we would be able to find out how to read this because there was a key involved. Okay. Bar graphs. Bar graphs are usually used with categorical data types like this one. What 1 hour feels like in school, wow, really, really long. At work, it's a little bit shorter. Home on a weekday, shorter but not short enough. Saturday night with friends, really short. Summer, what? Where did it go? Right? So this is an example of a bar graph where you have frequencies along the y-axis, or you can have relative frequencies, and then along the horizontal you have categorical data points. That's what a bar graph is. And there's actually a difference between a bar graph and a histogram. Here's another example of a bar graph. In this case, we're actually using several different bar graphs and putting them together. So this graph shows us the age that you can marry in a certain country, vote, and then held liable for criminal responsibilities. And it looks like in the USA, we have 18 here for marriage and voting. And then for criminal responsibilities, we have something a lot less, 12 years old. So go into juvenile hall, for instance, right? Notice that people, when there's a smaller amount, that usually indicates a higher crime rate. People are getting in trouble with the law at an earlier age. And so there is something that's done about that. So that's an example of several bar graphs put together. You have to do this very carefully and cleverly, but it does work. So what is the difference between a histogram and a bar graph? There's a couple of differences that I'd like you guys to remember. And those differences are horizontal axis is quantitative, whereas bar graph has categorical values. So this is a histogram, histogram, histogram. Here is categorical, 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 green is falling. And that's the difference between a bar graph and a histogram. There's another slight difference, and that is that instead of having categorical values, you have numerical. We also have no gaps in a histogram, whereas a bar chart, does have gaps right there. Okay, because they're separate categories. One is not the boundary for the other. A Pareto chart, it's the same exactly as a bar chart, except the researcher organizes the heights of the bars, the frequencies, in highest to lowest. You usually want to be able to see, okay, what's the highest. And those that are actually pretty close together, they are repositioned to be closer together, so you see which one's higher, which one's lower, instead of looking across an entire bar chart to see, okay, wait, is this the same height or is this not the same height as another column? So Pareto chart is the same as a bar chart, but the columns, the heights of the columns are drawn in descending order, so decreasing or descending order. Okay, so pie charts is another one. Basically, it's a circle, like a pie, and the area that's covered is the percentage of people that feel a certain way. So most people, it looks like, laugh and hope. To this question, what I do when I can't hear someone. Somebody asks you a question or they're talking to you. What do? Tell them you can't hear them. That's a small percentage of people. Move closer so you can hear same percentage. Repeatedly shout, what? That's a bigger piece of the pie. And then most people laugh and hope it wasn't a question, right? I don't know if that's happened to you before, but this is what a pie chart is. And usually what you want to do is actually write in the percentages of each of the pie slices so that people have a more accurate vision of how much of the pie each of those pieces actually take up. Another way of representing data graphically is using scatter plots, data points where there are actually two variables, variable 1 and variable 2, right? And there'd be a pattern that you would notice, and then you would be able to bank on that pattern. Usually, scatter plots compare two different variables, so problems and money, for instance. As the money increases, the problems increase as well. It's not always the case. But this is another example of scatter plots. And a little bit later, we'll talk about regression line, actually finding a line that best fits the data values, and seeing whether it's going to be increasing, decreasing, staying flat, and so forth. So that's scatter plots. Last one, time series graph. Looks like time series graph will always have dates along one of the axes. So in this case, we have 2003 through 2009, and then it says CO2 emissions in kilotons, kiloton millions. In millions, I would take it. Well, it looks like overall, in the past couple decades, if we will, looks like we're on a downtrend here. So time series graph, how things are changing over time. There's another graph, and the reason I show this example is just to point out that there are a lot of other different graphs that you guys would be able to make up yourself. So Florence Nightingale, maybe you've heard of her, found out that there is a lot of preventable diseases that people are dying from. And so she created this polar area diagram, and it showed basically, look, all of the brown, people are dying from preventable diseases. We would be able to not use the same knife on one and the other person to, sever an appendage. That there's germs, there's diseases that transfer if things are not sanitized. And she created this polar area diagram and tried to convince people and other doctors to be very careful with how they are, doing medicine and practicing their surgeries. So there are a lot of different ways of creating, presenting graphs. Really quickly at the end here, we're going to take a look at CV dot again. It's very important. So we looked at describing data, important characteristics, the center, the variation, the distribution, the outliers, and the time are what we are interested in data. We like to explore data, and so a lot of times when, for instance, we do a scatter plot, that can show you possible correlations between two variables. Are they related? And maybe one is causing the other, but not necessarily, right? And then comparing data. Construct several graphs to compare the data sets. Maybe try of the list, creating several of these different graphs so that you can see, wait, I see a different pattern by creating this graph over the other one. And you would be able to glean more and more information. Okay, so these are different things that are possible when we're looking at different types of statistical graphs. So in this next chapter, we're going to actually focus in on some numbers, not just the representation of statistical graphs and how they look and how to read them, but also certain things like the center, the variation, the distribution, the outliers. We're going to be focusing not on CV dot, but CV do. The T will be omitted for now. Okay, let's go on to the next video in chapter 3.